Hello, everybody, and thank you for joining us today for Power Up Your Profits DCFC Fast Charging Opportunities for Contractors. My name is Megan Broom. I'm the Marketing Coordinator here at Electric Avenue, and I'm pleased to introduce our speaker today, Mark McDonald, who is the founder and president of Electric Avenue. A little background on Mark. In 2001, a newly graduated Mark McDonald thought he was set for life when he landed his dream job at Nortel Networks, the largest tech company in Canada at the time. 1 year later, after failing to respond to disruptions in the industry, the company was on the path to bankruptcy, and Mark was jobless. Witnessing a tech giant like Nortel fall due to the lack of foresight and action was all Mark needed to take his future into his own hands. So then in 2003, he started his first business designing and installing home automation systems, which he helped sell 3 years later. For the next decade, Mark honed his technical problem-solving skills to help engineers, developers, and electricians design and power spaces all over Atlantic Canada, which led him to merge two companies in 2016, forming Catalyst Sales and Marketing. In 2018, he started a renewable energy company, and in 2021, he founded Electric Avenue, an electric vehicle charging company that sells both hardware and software. Today, he sits on the board as the Strategic Alliance Chair for the Atlantic Canadian chapter of the Entrepreneurs Organization. He also serves as a Sustainable Energy Advisor on the Community Council for the FIDA Living, a development company raising the standard of affordable rentals in North America. While his dream job may not have panned out the way he thought, it did set him up in ways he could never have imagined. Mark credits Nortel for teaching him an invaluable lesson about business and life, to never rest on your laurels, and that the status quo is never the option. Now, before we get started, if anybody has any questions throughout the webinar, feel free to put them into the chat and we will address them all at the end of the presentation. Thank you, and I hope you enjoy. And with that, I will pass it on to Mark McDonald.
Megan, thank you for the intro, and thank you everyone for joining. We wanted to put this webinar together, one, for us as a business, as a EVSC, electric vehicle charging hardware and software company. The growth and opportunities we've seen come through our pipeline in DC fast charging infrastructure has been increasing exponentially year over year. And we know that there's still some contractors and maybe distributors and our rep partners who aren't as comfortable or familiar with the opportunities themselves or the total size of the market. So really what we're trying to do today is bring value to our vertical. And for anyone who doesn't know our vertical, we work with rep agencies across North America. We only go to market through wholesale distribution, and those distributors only work with professional electrical contractors. So what we'd like to cover today to bring that value I referenced is, one, just understanding DC fast charging. I think if you're familiar with charging, maybe level 2 charging, which is the most common charging deployment we see in North America, you may not be as familiar with DCFC, or if this is your first exposure to EV charging infrastructure, we just want to talk on the substantial differences between the two. Also, industry projections. We put this together. Part of it, of course, is a sales pitch, but the bigger part of this is really preparing you for the business opportunities, both in the short term, but more so in the long term as EV adoption continues to increase annually in North America. Also, we want to walk through some considerations and best practices for DCFC installation, then really get into the business opportunities. Probably this is the most valuable part of the presentation, is really understanding what you can do as an electrical contractor to, one, differentiate, and two, secure some of these high value DCFC installations that are going on. The first thing on the topic of understanding DCFC, or direct current fast charging infrastructure, is it fundamentally looks totally different than what we're used to with a traditional internal combustion engine and when you switch to an electrified transportation system. So nobody really wants this experience, and you'll see the numbers that support it. But if you have an internal combustion engine, this has been the way we refuel it for over 100 years. With an electrified transportation system, this user experience currently is far from ideal. Nobody wants to wait in line for that DC fast charger. Nobody wants to sit for 20, 30, 40, 60 minutes on that DC fast charger and then go home at night and let that vehicle sit overnight. So the biggest thing to understand with an electrified transportation system is over 90% of all refueling or recharging of that electric vehicle doesn't occur here. and you'll see the stats behind this, but DC fast chargers are going to be the smallest portion of a charging infrastructure that's been deployed to support those electric vehicles. If we look at DC fast charging specifically and why it is so fundamentally different than level 2 charging is because level 1 and level 2 charging brings AC directly into the vehicle. It's up to the vehicles to convert the AC to DC. Technically, level 2 chargers are not called chargers. We call them EVSE, electric vehicle supply equipment. So with level 1 and level 2 charging infrastructure, it brings AC into the vehicle. It then relies on the charge controller in the vehicle. And those charge controllers can range in size. They are not all the same. So those charge controllers can range in size. They convert the AC to DC, which then passes that DC current through the BMS, the battery management system, which ultimately supplies it along that DC bus in the vehicle. The difference with DC fast charging is exactly as the acronym describes. It is direct current into the vehicle. So we bypass the charge controller in the vehicle and we go directly to the battery management system, allowing for significantly higher charge rates and significantly shorter charge times. Now, there is some downsides to DC fast charging. One of the biggest is, of course, battery maintenance or battery longevity. When you supply higher power and ultimately higher current, you produce higher heat, which degrades those batteries faster. So it is not ideal to be using DC fast chargers frequently, nor is there a use case where you should need to if we have the proper level 2 infrastructure deployed in North America. Power levels, they range pretty broadly and they continue to increase outside the batteries themselves in the vehicles and some of the charge controller development technology. Really, power output levels in these DC fast chargers are the other big advent or increase in technology that we're seeing related to electric vehicles. So 30 kilowatts, we're out here in the east coast of Canada. Most of our original DC fast charging network was 30 kilowatts. Now we're seeing deployments of 360, 480. There's some 500 kW product coming to market. So these power classes are creeping up, but also the range on the vehicles are requiring these higher power classes to support the vehicles that are coming to market. What type of charging speeds are we talking? Well, if we look at the Kia EV6, specifically the long-range Kia EV6 with the 77.4 kilowatt-hour battery, if we plug that into a level 2 charger and we want to go from 20 to 80% at 11.5 kilowatts, so on a 240-volt circuit, you're around 4.5 hours to charge from 20 to 80%, which is perfectly acceptable and very practical for the majority of the charging that would occur in any electric vehicle. If we move up to 60 kilowatts, I'll also reference the cable amperage here, and we go to 120 amp cable, you're talking about 46 minutes to charge from 20 to 80%. So not too bad, but not ideal probably for off-highway or critical infrastructure between two destinations. And then if we move up, we double that power output to 120 kilowatts. And we plug that into a 300 amp cable. Now we're talking 23 minutes from 20 to 80%. And if we bump up to another 60 kilowatt interval, if we go up to 180 kilowatts on a 300 amp cable, now we're talking about 16 minutes to charge from 20 to 80%. And 180 kilowatts seems to be the sweet spot right now, at least in our product catalog and many other EV charging manufacturers for value. 180 value, as far as, you know, how much utilization you can get on that charger, how long the average charge time takes, and what the cost of the charger plus deployment of that charger is. So 180 kilowatts is really the sweet spot. And we reference 20 to 80 because this is the habit or the recommended use case if you do have an electric vehicle. You don't want to charge to 100 and then drop it to 0 because of the charge curve. It takes a long time to go from 0 to 20 and 80 to 100 relative to 20 and 80. So 20 and 80 is really how you do distance driving an electric vehicle if you're not familiar with that. And the big lie, I can't stress this enough, amps is greater than watts when choosing your DC fast charging infrastructure. So many manufacturers just want to tout total power output, but it is a relative output. It is relative to the amperage of the cable. That's why I was referencing it earlier. Most 120, 180, and 200 kilowatt chargers that have been deployed over the last 5+ years, if you plug into it with the typical vehicle in North America, you're only able to pull about 80 kilowatts. So if you're a contractor or a specifier and you're involved in selecting this equipment, the amperage of the cable is more important from a charging experience than the total watts that that fast charger can supply. And why is that? Well, it's basic Ohm's law. In North America, unlike ROE or ROW, rest of the world, in North America, the majority of electric vehicles, light duty vehicles, so the vehicles we all drive every day, use 400 to 500 volt DC architecture. So if I have a 400 to 500 volt battery and I'm going directly from the DC charger into that battery management system, the total power I can draw is going to be a function of the cable amperage and the battery voltage. So if we take, for example, a 180 kilowatt charger, and we only supply that 180 kilowatt charger with a 200 amp cable, when I plug a 200 amp cable into a 400 volt battery, even though the total output of the charger is rated at 180 kilowatts, we're going back to Ohm's law. It's 200 times 400. I'm only ever going to pull 80 kilowatts. If I go the next power class up, or amperage up on that cable, let's say 300 amps, you may see some 350. We're sticking with air-cooled cables right now. So these are air-cooled cables, not liquid-cooled. So we really have a maximum we can get to on an air-cooled cable, which is around 300 amps. Even if I take that 300 amp cable and I plug into a 400 volt battery, I'm now going to go 300 times 400. I'm still only getting 120 kilowatts out of it. In order to get the full 180 kilowatts out of a 180 kilowatt charger on any 400 volt vehicle in North America, I need to move up to a liquid cooled cable, A, or B, like us and other manufacturers do, I need to offer what we call a boost mode or an overdrive mode on that 300 amp cable, where I can actually monitor the temperature on the conductors, their high performance cables, keep them with within the NEC and CEC temperature limits, and overdrive that cable for a period of time to get that full 180 kilowatt out of what I mentioned earlier is the best valued product that we see out there, which is a 180 kilowatt charger. And what vehicles I'm talking about over here on the left, you may have already had a look. Essentially, only the Kias, the Porsches, the Audis, Lucid, and Hyundai run 900 volt DC architecture. And you can see these are the European and the Korean manufacturers. Pretty much all North American manufacturers use 400 volts. So this is incredibly important when selecting DC fast charging infrastructure, that we don't just specify or recommend the total output of the charger, but the amperage of that cable that's going to supply off of it. What do we have for connectors? Well, this is North America, so we love standard wars. In every other mature EV market globally, we haven't run into this, but here in North America, we have 3 DCFC connectors that are approved for use, that we have vehicles manufactured with or previously manufactured with. And those 3 connector types are CHAdeMO, then we have the NACS J3400 and the CCS1 connector. CHAdeMO, this is a Japanese standard. The original Nissans, the Leaf specifically that came over, this was a Japanese standard, had CHAdeMO connectors. Since all Japanese manufacturers have switched to the CCS standard, so really we have some legacy CHAdeMO DCFCs deployed, and there's also some requirements on publicly funded projects like under NEVI and ZEVIP up here in Canada that we still need to maintain a percentage. Typically it's 1 to 3. So for every 3 CCS connectors, we still need to deploy 1 CHAdeMO connector. And then the NACS connector, most people probably would recognize this as the Tesla connector. It became the North American charging standard when Tesla removed the licensing from this connector, and then it was subsequently adopted by the Society of Automotive Engineers, and that's why we have the J3400 standard. So now this is accessible to all manufacturers without any additional licensing cost. We have seen several manufacturers announce they will move their charge ports to the NACS J3400, but we're talking mid to late 2025 before we really see any non-Tesla manufactured vehicles with the J3400 charge port. All that being said, the majority of what we sell is the CCS1 connector, and now we're starting to see more sales on the NACS J3400, more typically on the level 2 charging. But the good news is, like North America and all their other standard wars, there's converters and adapters for all of these. So you should, as an EV driver, be able to use any DC fast charging connector that you run into in the market. So by the numbers, why did we want to host this webinar? Not only for the contractors, but really to get our reps and sales teams and our distributors partners across North America excited about how big this opportunity is. I mentioned it earlier, it is a small percentage of total connectors that will be deployed, but it is a massive financial opportunity. So in North America, these numbers, of course, have some sensitivity. There's a lot of negative media hype in the last year or so, 6 months to a year, around EV adoption in North America, but the numbers are still staggering. We are on pace for 30 million EVs on the road by 2030. That's compared to 2 million just last year. That is a 15x increase on the amount of EVs on the road. And with new EVs for all of us comes new infrastructure. To meet that demand, we're talking 250,000 DC fast chargers in the US alone over the next 6 years. And that's compared to the approximate 30,000 DC fast charging connectors available today. And as much as a manufacturer, we love level 2. Here's an additional number that kind of blew me away. That's a 60-fold increase from where we currently are in DC fast charging connectors compared to level 2 public chargers, which are easier to deploy. They're more cost effective to deploy. We're only going to see a 30-fold increase on level 2 chargers in the same time frame, and it's numbers like these that were really the impetus for us to put this presentation together for you today. What is the DC fast charging market size? It only represents, if we just look at public infrastructure, it only represents approximately 10% of all ports that will be deployed in North America. So we're only talking 10% of the market size by volume, and that's just public. If you are a contractor or a distributor who sells also residential chargers, the number is significantly less. It is approximately 1% of the total EVSE connector market in North America. If we factor in all those level 2 home chargers for single family and level 2 home for multifamily, we take our level 2 public and our DCFC, you're talking 1% of the volume or connectors that are going to be deployed. But this is the crux of it. This is why we think you should be excited. On the left, we have the volume of chargers I just referenced. On the right, we have the cost of those chargers. DCFC at 1% of the total amount of connectors represents almost 40% of the cost to deploy this infrastructure. So if you're a contractor who's in the EVSE business or wants to get into it, if you are not focusing on DCFC, you are leaving approximately 40% of the available revenue, not volume, revenue to your business on the table. How can we access this? What's going to help expedite the deployment of these chargers? Well, a big one is funding. In the US, under the Inflation Reduction Act that the Biden-Harris administration passed, between the NEVI, the National Electric Vehicle Infrastructure Fund, and the CFI program, there is $7.5 billion carved out over the next 5 years to support NEVI deployments on corridors and CFI deployments, which have different stipulations. Also, that's at the federal level. We also have state-funded projects where funds are being redistributed through the IRA for the state's development of charging infrastructure. So $7.5 billion to access there to help subsidize the cost of these deployments. And then in Canada, We have our ZEVIP program, which represents almost $700 million. This program has been going strong for a while. Similar to the US, this is all contingent on government. Right now, the government that we have in place have developed this program, same in the US. So if those governments stay in place, we expect to see these funds continue to be distributed. Now for the contractors specifically, I want to talk about best practices and considerations for DCFC installations. One of the biggest ones, of course, is site selection. If we're going to calculate a total ROI on a project deployed, site selection is absolutely critical. The first thing we want to think about is accessibility and visibility. So accessibility, how close is it to major routes? Is it ADA compliant? What are the socioeconomic factors related to this area that's going to be deployed in? Because unfortunately, right now, EVs are a wealthy person's second vehicle. So those considerations matter. What about lighting? IES recommends at least 10 to 20 foot candles. We see so many DCFC sites tucked in the back of existing parking lots that are underlit. That's why we think electrical contractors are so critical in the selection, because they already understand in most instances the importance of lighting at these sites. Also, proximity to major routes. Both the ZEVIP funding program I just referenced and the NEVI program require to access that funding, chargers to be located within 1 mile or 1.6 kilometers of major highway corridors, because that's what this funding, specifically the NEVI program and the ZEVIP programming, are out to support. And that's making the destination journey a whole lot easier for that EV driver, destination to destination, where I can't make it from my workplace or from my home to that ultimate destination. I've got to access that DC fast charging. It needs to be easily accessible to be a good experience for the driver. And existing infrastructure, is there already a parking lot there? Is there already parking spots that are available? Is there already adequate lighting available? Is there existing amenities around the site? All of these get considered when selecting an appropriate DC fast charging site, which ultimately tie back to the ROI I referenced earlier. This one's a no-brainer, pretty straightforward. Electrical supply capacity is one. Utility service availability. Do I need a service upgrade? What's going to be my cost? Do I have enough existing kVA on that transformer or room in that switchgear to support the deployment of a 60, a 120, a 180, maybe multiple ports? That's going to keep your costs down and also keep your ROI a whole lot shorter. Distance from power sources. If I need to pull a new service, how many poles will be required? How much trenching and civil work is required? How much cable will be required? These are all the big expense items when we're talking about that electrical distribution equipment. And then voltage requirements. In the US, it's a whole lot easier. Pretty much 480 is universally available. Up here in Canada, we've got a lot of 600 volt series services, but there's very few manufacturers who build 600 volt DC fast chargers. Do I have 480? Do I have 208? All these need to be considered when selecting the appropriate site for DC fast charging equipment. Then we get into the charger specification itself. What's my total power I want? Going back to that story I harped on earlier, what cable amperage am I looking for? What's that system voltage? And then connector types. Is it a NEVI ZEVIP project? Okay, I know I need at least one CHAdeMO connector for every 3 CCS. Is this going to go in a dealership? Is it a fleet application? Are they moving to an NACS or J3400 compliant vehicle? And then future proofing. Can my site be upgraded? I think it's critically important you think long term when you're deploying this infrastructure. Okay, here's what I think my utilization is today, but if I follow that compounded annual growth chart of EV adoption, do I have the electrical capacity? Do I have the physical site capacity to add more chargers and more vehicles down the road? Equipment selection. These are some standard breaker sizes, full side load calculations, and we can share this with anyone, including the presentation. Calculate kVA and then their closest transformer size. So if we start down at 30 kilowatt DCFC, you're talking about 45 kVA for that supply transformer. And if we go up to 360 kilowatts, you're talking 500 kVA. The most common, of course, is 180 kilowatt charger that we sell. So you're looking at a 225 kVA supply transformer. And then breakers, we have the technical spec requirements for these breakers, but at 80% rated, you're looking at a 300 amp breaker on that 180 kilowatt service. Site layout and design, I'll speak to this in a moment. This is something that we offer, but we can do the layouts just like you see in this little screenshot. Number of chargers. You really need to decide on the quantity, unless of course it's an engineered project and they've decided for you, based on anticipated utilization. This is a bit of crystal ball, but I'm going to show you some contractor tools here in a moment that make this a whole lot easier. Cable management, it is, to me, a requirement, a necessity, especially if there's any engineers on the call. When you're speccing out public chargers, you need a cable management system, because unfortunately the general public over time will just not retract that cable. It will lay on the ground, it will get damaged, it will be a trip hazard. There's a whole lot of issues with it. So appropriate cable management and appropriate signage and markings, not only on the parking spot, on the charging equipment itself. All these make for a better installation. Then probably the most difficult piece, I think, for most contractors would be the civil and structural work, unless they have this in-house already. But there is civil and structural work typically that needs to be deployed on DCFC chargers that we don't see on a level 2 chargers. But you've got to look at the foundation requirements of that DC fast charger. What size concrete pad do I need? What are the footing size? What are my lag bolts going to look like? Or my anchor bolts going to look like, to make sure I get that deployed there? Do I have the appropriate equipment to move the fast charger once it gets to site? Typically they're all top anchored, so you can move them around, but you've got to have the appropriate mechanical equipment there to do it. Trenching and conduit installation, there's some complex routing sometimes from power mount transformers, from pole mount, depending on how you're feeding these. And very importantly, which sometimes gets overlooked, those protective bollards. We're not all the best drivers. We want to make sure that that equipment is protected, because it is a large cost to invest in it and deploy it, as you saw earlier. This is another very important one, networking and communication. The majority, almost 99% of the time when a charger is down on our network, is a communication issue, a networking issue. So connectivity requirements, am I doing Ethernet, Wi-Fi, cellular, or do I want to go no network? We now have an option on all our chargers where you don't have to deploy a network. We actually use the user's phone. It's Bluetooth to the user's phone, and that user's phone becomes our network connection. So we've got to decide what type of network, or maybe we want multiple networks for increased reliability. And then software integration. Are my chargers compatible with my network management system? Are they OCPP 1.6, 2.0.1? Are they ISO 15118? Do they work with plug-in charge? Are they V2X, V2Grid, V2Home compatible? So can I backfeed them? All those are considered definitely when selecting the right equipment. And then another big one is future scalability and expansion. Does the charger have modular design? Us and others, if you buy a 120 kilowatt from us, you can upgrade that down the road to 180 kilowatts. So we use the rack-based power distribution system, so you can actually increase the output, your DCFC output on our chargers. So is it a modular design? Can I upgrade it? Do I need room for energy storage systems to supplement or complement the available grid connection? Do I want to do some renewable energy integration down the road, which is now becoming a standard of the OCPP protocol? So all future scalability and expansion considerations. User experience enhancements. What's my interface? LCD, do I want to run advertisements? Am I going to do a credit card terminal? Am I doing only app-based payments, shelters or canopies? Do I really want to attract and compete? Is my site a place where I've got a site across the road and a Tesla charging station pretty close? Do I want to make sure my site is more attractive? If that's true, you also want to look at amenities, Wi-Fi, food facilities, washrooms. These all get considered when deploying DC fast charging infrastructure. And now, just to close out, the business opportunities themselves for the contractor. One is the industry. So EV charging stations have a projected market value of $20 billion, $19.2 billion by 2028. So this is the money I'm talking about that we don't want to leave on the table as an industry. Installations, just the installing cost of a DCFC, not the cost of the charger itself. Average, this is USD, anywhere from $45,000 to $150,000 per DCFC. So if you have a multi-site installation, of course, this cost goes up. It's not linear. You know, some of these costs get reduced down, but that's the type of money we're talking about just in the labor and installation of these chargers and balances systems. This is another big one. Anyone interested in service contracts? We do sell service contracts with our chargers, but service contracts we think are huge. All DCFC chargers require maintenance for warranty. It's typically on ours a 6-month cycle. Now, if you're just doing air cooled, we're talking about fans, fan filters, cable lubrication, retractor tension testing and tightening. You need maintenance. I think if anyone has been in this industry for any amount of time, we've all heard the horror stories of the reliability of chargers out there. So maintenance is critically important, but for you, the contractor, selling those maintenance contracts is a great opportunity. What are some key markets? Highways, no brainer. Shopping centers, urban centers, state parks, airports, gas stations, supermarkets, business parks, fleets. Dealerships is a big one. Most of these dealerships, privately owned dealerships, small business owners, you know, are required to install 1, 2, 3 DC fast charging pieces of equipment at all of their dealerships. How can you get better at selling DCFC as a contractor? Well, if you're in the US, I would highly recommend. We have no financial ties to this company. We have no investment in this company, but EVPIN is a phenomenal tool to help you, one, identify potential sites for DC fast charging, or in this screenshot that you see here, help you find existing NEVI projects that have been funded. So you can go on the EVPIN website, you can use a free account, or you can pay for the pro features. You can do site lookup. You can see what a utilization score would be. It lays out socioeconomic conditions, so you can see where the early adoption areas are for EVs. It does layouts, it does proposals, it does ROI. This is a great tool if you really want to scale up your DC fast charging or your EVSE business in general as a contractor. Up here in Canada, EVPIN is not available yet. But we'll keep our eyes out on it because it is such a great tool. But Enercan does have its ZEVIP map. Similarly to EVPIN, you can go on here and see every single federal project that has signed a contribution agreement. It doesn't mean the charging infrastructure has been installed and deployed. So at least if you're trying to build a pipeline, you can see which projects have been funded and, you know, go about the sales process from there. But it also gives you some identification of where chargers are, but more importantly, are coming. So it helps you identify if you're working with a private developer, private owner, dealership, whatever it may be. Okay, is there charging here today? No. Is there charging going to be here tomorrow? Yes. Maybe we want to make a different decision with that site. The next one is ROI calculators. We offer this for free on our website. You can go in, you can select level 2, level 3, you can select DC FC from 30 to 360 kilowatt. You tell us how many chargers right on our tool that you want to install. You tell us what your labor costs do you think roughly budgetary would be. We factor in all of the tax credits. We factor in potential funding, and we'll give you an ROI. And we'll give you that not only in number of years, but also as a percentage. So what is my return on investment on my CapEx? And we also factor in that OpEx. So this is a great tool to help you decide if a project is viable. We factor in the energy cost, the cell cost per kilowatt hour. It's a very detailed, complicated ROI calculation. The other thing we'll do is project proposals. So if anyone needs support in winning some of these projects, we can take our ROI tool, we can take our project proposal software, and we can help contractors and distributors win some of these jobs by outclassing maybe your competitors on that job, by really laying out, one, the details and the lengths you went to identify that site as a potential a site for DCFC infrastructure, and then also get into all the details of the project and the value in working with you and potentially us as a manufacturer. And the last thing we'll just say, the biggest growth driver for our business over the last 5 years has been funding assistance. We do this absolutely free. If you become familiar with the funding programs in your province, in your country, in your state, and you get really good at it, and you can walk in there and offer this, because it is a burden, it's a heavy lift for a lot of potential sites they don't want to get into, but becoming an expert in the funding program has moved the needle. Funding programs have moved the needle faster than anything else we've done with our business to help grow it. And with that, I thank you for attending. I think Megan will open it up for some questions.
Thanks so much, Mark. That was great. So we are going to get started with some questions. Firstly, I'll start with a question from Justin. So Mark, in USA cities, we're seeing a higher rate of theft of the charge cords for commercial chargers. Do you see anything coming to the market for theft prevention?
That is a great one, and that is a question we've been getting for almost as long. Before it was even a reality, you know, people were speculating that this would be a thing. The short answer is no. We try to stay on top of conferences and industry associations. We're a member of the EFC and the committee related to EV charging infrastructure here in Canada. And I just have not seen any good solution to this point. But I guess that goes back to what we talked about earlier, like those maintenance contracts, site lighting, camera systems, you know, all of the traditional things we see at refueling station for internal combustion engines. We'll probably want to make sure the same are deployed with EV charging infrastructure. But no, I don't know a great solution other than, you know, the typical things you would expect to lower theft at any site.
All right. And from James, can you please expand on the boost charge feature for the Wadi Direct? How is it permitted on a 300 amp rated cable? Is boost charge automatically active, or does customer activate when initiating a charge session? And would boost charge decrease the charge time by a factor of 300 amps to 500 amps, for example, 60% for the times noted on previous slide?
James, perfect question. And I think you answered most of it within the question. How is it permitted is the only one. So the NEC and the CEC all have temperature standards for high performance conductors. So I believe it's 90 degrees Celsius. So we have a temperature sensor in the CCS handle. We have a temperature sensor at the other end of the cable. So of course, factoring in overshoot. And in colder environments, the boost mode will run longer. If we're in Arizona and it's, you know, 110 degrees, the boost mode will run shorter. But on average, our boost mode will run for about 10 minutes. If we do the math, like you talked about, James, if the average charge time on a 120 kilowatt charger on that 77 kilowatt hour battery in that Kia EV6, if the average charge time is around 20 minutes, then yes, that's how much time you will decrease that vehicle being on that charge port. And what that means for operators is it's all about utilization. If you want ROI on your hardware, you want to get more vehicles on that charge port, and boost mode is an excellent way to do it. But it falls under the NEC and the CEC code guidelines for it.
And from Gemini, we have, when selecting equipment for a DC fast charging project, what key factors should contractors keep in mind to ensure they choose the right setup?
That's a great one too. We talked about the majority of it, but really, you know, one thing I guess we didn't touch on is budget. Like any deployment, you know, it's going to have to start with budget. Some of the projects you're going to involve with are just going to be government funded. So then the deployment, the equipment being deployed is going to be selected for you, typically by a specifying engineer. But there's a lot of variables there. I would say, you know, go through this presentation in detail, and the majority of it is covered. But the big one that's probably not covered is what's that customer's budget.
And for our last question from Carmen, we have, as a certified electrical installer, how do we apply for the NEVI funds for California installations?
That is a great question. We will get your contact info. We have a rep in California, and we'll get the information to our rep in California, and we'll get some information in front of you. Well, Steve has his hand up. Steve, did you have your hand up? I see a hand up. Okay, I think we're good.
Wait, Mark, we do have one more question from Kevin you just submitted. Do you have any information on the ability of the utility infrastructure supply to be able to provide the electrical power to support the expansion of EVs?
That is a good one. We don't specifically have it under, I don't know where they're getting the data. Some of it is publicly available, but if we go back to that EV pin, Kevin, I don't know if you're in the US or Canada, but in the US, some of that data is available through EV pin. In Canada, we've worked with multiple utilities. We're in Nova Scotia. So Nova Scotia Power, when we do site scopes, we'll provide that information. And just quickly and anecdotally, I'll provide a horror story. We were with the city of Edmonton about 6 months ago, and they had already purchased, let's say it was close to 40 electric buses, and the charging depot had no power on the distribution equipment on that section of the grid to support it. So they've got about 40 buses, I believe, and they're able to charge one at a time right now. So that is a really important question to be asking and point to be bringing up before anyone deploys looks at purchasing any major EVs for those fleet applications, that yes, that distribution network from the utility can actually support it. We've heard more and more horror stories like that. Then you get into things like I talked about, the BESS systems, the solar systems. How do we augment? How do we supplement to get this infrastructure deployed?
We have a question from Steve. Can you quickly explain the 30%, 40%, and 50% ITC standards?
The input tax credits in the US, that is beyond my pay grade. So I would have to be an accountant. But the short of it is, without getting into too much detail, the 30% of the cost of the installation, I believe, you can write off. So if you spent $200,000 or $100,000 on an installation, your business had $100,000 in revenue, 30% of that can be written off. So you're getting 30% of that back as an input tax credit. But that's a US thing. So maybe Steve, you can speak to it more if you want to jump on. But in Canada, we have what we call the accelerated capital cost allowance, which allows you to do something similar. Normally, you depreciate an asset over the life of it, but you could actually depreciate 100% of EV charging infrastructure within the first year. So same idea. If that install was $30,000, then you could get $30,000 back from the income taxes you paid that year, assuming your company was profitable. But I'm not an accountant.
Philip, sorry, yes. And from Philip, do you have any DCFCs already installed in Canada region we can refer clients to visit to use as a reference?
Yes, Canada is our biggest market for it. We have a bunch of case studies. I'll have Jill send links to some DC fast charging case studies, but we've got fast chargers, I think, in almost every province now.
Perfect. And I believe it's all the questions we have today. If you guys have any more questions or like to stay in touch, feel free to scan the QR code on this slide here. A recording will be sent out to all of you in 24 hours. And again, just thanking everybody for coming, thanking Mark for a great presentation, and I hope everybody enjoyed.